Hello and welcome. Welcome to our presentation on the tech of Odysseus. So, my name is Sampo Juustila. I've been coding over a quarter of a century, started when I was 10. I've been doing it professionally for around 10 years. Up until university, I thought coding was a fun hobby, but not something to do as a profession, but that's what you get. And on Odysseus, I was one of the core developers, mainly focusing on the engineering views and tasks and backend. I recognize a good design when I see one, but I don't know how to make one. So fortunately, we had much more professional people for that.
Hello, I'm Essi Santala. I was the lighting designer for Odysseus. I've been working as a lighting designer in theaters for about, 8 years, and been doing lighting design for about 10 years. And this was also part of my master's thesis in lighting design for the Theatre Academy. During our presentation, we will talk, Sampo will talk more about code and all of that stuff, and I could talk about tech and stuff, but I think it's more interesting to see like how code meets light and sound, and mostly light. Let's face it, I don't know much about sound. Hannu is in the front row, one of the sound designers, when you want to ask questions after this.
If you have questions for a specific part, raise your hand, but we have Q&A at the end. One thing I want to emphasize is that we're going to present some lessons learned and critique on choices that we made, and that critique is for the decisions we made as a whole team. Many of them that I was also participating in, and not the particular person who implemented something. Shortly, the agenda for today, brief intro, then IT descriptions, AV descriptions, and then some case examples of how these two met in Odysseus, and then questions afterward. Hopefully we have time for those.
Hopefully you ask questions from us and not the other way around.
So briefly, what was Odysseus? It was a Battlestar Galactica-inspired LARP for 104 players. There were 3 runs, each lasting 48 hours. And the point was to have an immersive 360 game location. The LARP was a Finnish-style LARP, meaning that all of the characters were pre-written with plots and so on. And as one of the key decisions in the game design, it was that it's a story about survival and what humans are ready to do to survive. And there were no morally easy options to choose. In one of the runs, diplomacy was attempted, but it failed. Shortly in numbers, over 300 players in the runs, over 160 volunteers, meaning that there was about 1.5 volunteers per character in the game. Around 86,000 budget, 33,000 lines of code were written for the LARP. 6 kilometers of cable.
Yes, this is quite an actual number. We counted it. 6 kilometers in total, and 39 rolls of gaffer tape.
In one school. But we thought that more than description and numbers, a video could help understand a bit what it was about, demonstrate a bit the tech, the light. Well, sound isn't in this video, but also like the spatial design, the props, the overall feel and style. And this was just released from quarantine 3 hours ago.
And this is all actual in-game footage shot during the game.
In-game footage. As a warning, there are a couple of shots of medical operations in this. Thanks for Valtteri for making this video happen. Then as we were designing this talk, we realized that we had very different points of view from what we were coming from. So when I started this and was progressing, of course, yes, it's a LARP and so on, but the big tech thing, it's a software project. Medium-sized at that, because there were so many different moving parts, there were so many components, and all of the aspects of a software project needs to be handled well or poorly. Maybe you'll say...
Yeah, maybe our take on this was like all the gear and everything we got for light and sound. It was more like, oh, this is a small festival that we're making. And I've never worked in a software project, so and I guess you have never worked on a little festival. So so we had some communication challenges to overcome to speak the same language.
Yeah. Still, some key differences were differentiating this from a standard commercial software project. One of the things was that in the first meeting of the tech team or the IT team, we talked that, okay, what about non-functional requirements, security? We have an internal network. We trust all clients. We trust all users of the clients. We don't need security. Meaning, in practice, that every single client had read-write access to all data with no authentication. And that made a lot of things very easy. For example, Hanska tasks, which we'll come to in a moment, normally there need to be some challenge response stuff going on. Now, the client just said that, hey, this is done. Yay, great. We trust you. And another point is maintainability. So we're not developing the software for Odysseus after Odysseus. So quick hacks are okay. If it's fast, it's great. And also there were many parts where we were copy-pasting code instead of refactoring. As an exception, some framework code was When working on the backend, I often focused on quality as well. Firstly, because we were building all other stuff on top of it. And secondly, because I really want to see it used still in some other project as well.
From the light perspective, how this was different from a festival or an interior design project. We had centralized control. I mean, that doesn't happen in a festival. If you have multiple stages, you don't actually have one lighting desk taking care of all of the stages. And we also had automated input, so nobody was needed to like sit behind the desk and the show would still go on. We were just kind of there to watch that the machines were doing their job. That usually... I'm on the good guy's side here. So that is how this was very different from festival or an interior design production.
But next, let's do a bit of deep dive into the IT side. I'll try to keep maybe half of the talk on like more general level and still try to provide some details to those who are interested. So an architecture picture. One of the central things that we needed and got ready was the Empty Epsilon, which is an entire bridge simulation software. We didn't use Artemis because Artemis isn't open source. This we could hack and extend. We had a central Empty Epsilon server, which was serving both the bridge and the fighters. During the first tests that we were doing with Empty Epsilon, no one had used it before. There were major difficulties and the server was crashing every 5 minutes or so. But fortunately, it got better. The first run, it didn't crash at all, and I guess in the later runs, only once or twice.
The second run, it was crashed twice in an hour, but after that, no crashes until we had... after the second week of bringing down the place, we had to take down the server, but it hadn't crashed.
Yeah. Then the second major piece is the backend server, which we completely wrote from scratch. And I'll get back to that. And these two were integrated together using the Empty Epsilon REST API, which it was polling because Empty Epsilon didn't provide any kind of push mechanism. Then we wrote different kinds of endpoints, the LoRa Science Voyager, i.e. the jump UI, engineering systems, ESA Data Hub, which is where users logged in.
For people who don't speak IT, do you want to quickly say what's pushing and pulling for the data?
So pushing and pulling. So the backend server was making requests to the Empty Epsilon server once per second that, hey, has the state changed, has the state changed, has the state changed, instead of the Empty Epsilon saying that, hey, now the state changed. It's inefficient, but in this case, it worked fine. And then we had the engineering task boxes and hand scanner. All of these we'll go through in a while. And all of this communicated with the lights and sound via DMX signaling, which we'll also cover in a moment, with both the Empty Epsilon server and backend server acting as sources.
Yay, I get to talk about the right side of the screen. So we decided to go with DMX. We could have done other signal protocols as well, but we decided to go with this because it's old, trusted, and very easy to use, I guess. And Empty Epsilon supports it to begin with, so it was very easy to use. We ended up, 2 days before the first game, we ended up running everything through the lighting console. So we had all the signals coming in from the backend, empty epsilon, and then one other system to the lighting desk. And it's a professional lighting desk, so you can do like a whole lot of things with it. Like the lights were run through it. We had the airlock winch that would raise and lower the door of the airlock. And then we had smoke machines, and we also output MIDI, which is a very old signal form that's used for keyboards and whatnot. But you can output that from the lighting desk, and we output that to the sound system, which is over here. And there's the Ableton Live. It's a, what do you call it? It's like a mixing program. Yeah, that you use to run shows in theaters and everywhere else. And they had stuff coming in from a launch pad. So on the bridge, there was an announcement board. You could push buttons that said like, abandon ship. Or disregard previous announcement. Or that lunch is ready.
More importantly, I think you could do stuff like captain port to bridge.
Yeah, that's what they used a lot. Captain to the bridge, XO to the bridge. And so they could actually have some input to the sound system themselves. But then there was a lot of things that were input from the other systems, like the ambient sounds, and if a door was opening somewhere, or if there was a red alert on, so the sounds and light would change, and all of those were run to the big professional mixer, and that like sends the sound signal onwards to the speakers and the subwoofers. Oh, and there was also an announcement mic, so they could make announcements themselves if the buttons were not enough.
So moving on to the actual systems, empty epsilon, we had these various views that were used. For example, there is the weapons view, the engineering view. In the engineering view in empty epsilon regular game, you have small people in there, and you say to that person that, hey, go there and fix this and this. Of course, in Odysseus, all of these were live people who were running around the ship. So you couldn't fix the ship. The fix got broken in empty epsilon, and it was fixed in real life. There's the GM view, which had these custom buttons. So all the scenarios were custom built. And there's like buttons, enemy north, enemy west, and so on, which you could use to generate enemies when wanted, or do specific actions that were required for the gameplay. And there's also the external view, like cinematic view, and all of these models, 3D models, were custom made for the game. This is Odysseus. There are some enemy fighters, and that's a larger enemy ship. Don't know exactly what the name was of that ship type. Then the backend. So it was the single source of truth of all the data. And one of the choices that I think was a good one was that we had this kind of in-memory data blobs in addition to a SQL database. So meaning that we had you could store completely generic JSON data, each with a type and an ID, which I'll show in a moment. And all of this was in memory, so you could access it from code synchronously, you could access it fast, you could loop over it as often as you wanted. And it made life a whole lot easier. It doesn't have type safety, so in a large, complex project, it doesn't really work, but in this kind of project, it worked really well for stuff that was basically pre-known to exist. Stuff that was created, messages and so on by the users were still put into SQL database. Then we had a rules engine, which was basically just JavaScript code, which could trigger on intervals or trigger when the data blobs change and so on. And we have the empty epsilon integration, DMX output. And I'd say that roughly, I don't know, a quarter to a half of my time, I was working on framework code. And basically the story is that I want functionality X. And for that, I need some kind of APIs, I need data storage, I need a place for business logic, and so on. And that needs to be built. And often it's excess code or boilerplate code that is needed. But once the data blobs and this kind of stuff was built, I was able to create a new Hanska game from scratch in 2 hours. So at that point, it was more a matter of the slowest part is getting the idea and the design on how this game should work and not really coding it. Which is one of the reasons I really hope this would be reused in some other LARP. I'll quickly demo or show the
I have a quick question.
admin UI. Yeah.
Backend before you go on. How are you hosting it? Did you have an actual hardware server there?
Yes, it was a hardware server located on site. During development, we did development locally, and we had a server in the cloud. So, for example, this is the cloud server. This is hosted on some provider. Yeah. So we also built this admin from scratch. And for example, here's Odysseus specific stuff like the jump drive, social, so person information, fleet information, ship log, what has happened. You could control infoboard actions here, do different operations, access empty epsilon, manage the airlocks. You could also manually trigger DMX signals, which were used in a couple of specific events during the LARP. And then there's this data store part. So this part is completely non-specific to Odysseus. There's different types. For example, tasks. And this is actually the cloud server that is used in the exhibition area for the tasks that are there, and you can go there and do Hanska tasks yourself. There were a lot more during the game, of course. There's only some now here. These are tasks that are visible in the engineering UI. There's games, which are the Hanska games. Boxes are physical boxes. And if I, for example, here take the Fusebox engineering, okay, it seems that someone has turned the main switch off and left it off. That's unfortunate because I was going to blow some fuses from there.
They knew.
Yeah, so you could just open this and select a preset, like blow one fuse from there. Whoop. What happened? Hard to use it from this angle. Blow one and... Okay. And it would have just blown a fuse in the exhibition area if the main switch hadn't been turned off. Then ESA Data Hub. I don't know much about this because I wasn't really involved developing this, but it provided, for example, communication between different player characters. You could send messages between players. You could send messages to NPCs who are located on different ships of the fleet, your loved ones who are on a ship that we know that will be destroyed in the next jump, and so on. And also we had the easy virtual assistant, Eva, which was the ship-wide system where you could say that, hey, I'd want this and this kind of information, or I'd want to try to do this and this engineering trick and so on. And that was a messaging channel to the GMs who then responded however we felt best for the moment. And I think that worked really well. There's some statistics later. There's information databases. This was used by the science team. This was used by medics to get results on artifacts that they are studying and so on. There was news information here and voting systems. You could create online voting.
Also, it had the databases for characters, so medics could update your medical file and security could update your personnel file. Yeah, so that kind of stuff. And of course, in a LARP, there's hacking. So specific characters who were skilled at hacking could go into the personal database, select someone, and click on a magic button. And they got this kind of screen where they just had to hit random letters until they found the correct letters for each of these. Meaning that they were randomly hitting the computer keyboard with a screen like this in a public location for about a minute. Which I guess was a bit intimidating occasionally. Then Hanska, the universal hand scanner. Basically, we were planning to use and did use NFC tags very extensively. Basically, there were multiple Hanska devices, and depending on what your role or skill set was, you got different functionalities. There was separate for science, engineering, and medics. And each of these had then different functionalities. And, well, I have a Hanska here. So first, each player had this kind of, well, bracelet, which was a bio identifier. So something that cannot be stolen from you. And when you put the Hanska on your bio ID, it signs you in. And then you can, for example, if you're an engineer, you can repair a system. There were these kinds of tags all over. Maybe I'll use this. There were these kind of tags all over the ship. And when one of these was broken, you took the Hanska, went there, scanned it. You got some instructions. And then you got some game that you needed to complete. Like that. This was an easy one. And if this would have been, this was just a game which isn't visible, but if this would have had a task attached to it, it would have now moved in the engineering view to complete. And then, again, if you log in as a medic, you get a different view. And after someone comes from a land mission, for example, you can diagnose injury. No injuries detected.
Has your injury been lost?
No? Come on.
Come on, injury.
There. Didn't get it.
It's not blues diagnosed.
Severe overwork.
And then it's doing some processing. And then provides result that in practice, I believe these weren't really stuck on places, but they were more as these kind of bracelets. So, for example, when there was a radiation leak and someone went to fix it without the proper gear, an NPC would be there just handing over these tags, which you would then go to a medic. Come on. Now that's a demo effect.
To my understanding, these all worked very well in the game, unlike now. They must be getting old.
Something in the matter there. But basically, you'd get these on your hand, then the medics could scan you, could treat you properly.
What are they?
These are NFC tags. In practice, we had multiple roles. They're about 70 euros per 1,000 tags, which are stickers. So you basically we just stuck these over all the walls, and then we added this other sticker on top of it to make it look nice.
And it contains some data, right, when you read it with
Yeah. So these contain a small piece of text by which Hanska knows that, hey, this is now a game. I need to fetch this data from the backend and start this game.
Did you provide the phones or did players use their own?
We provided the phones. We actually had a much more rugged model that we were going to use. But during the last days, well, firstly, the order hadn't accidentally arrived. Secondly, we discovered a bug in the NFC system of the phone, which would have made it a bit hard to use. So I just drove to Giganti and bothered customer rep there with very specific requirements of cheap phones that work with web NFC, which is Chrome-only functionality. And finally ended up with 3 of these. One point, if you use stuff like that, note the location of the NFC reader. Most phones have it somewhere here around the center, which is a bit awkward. This phone has it very high up top, which is why we ended up with this. And like I said, these are available in the props exhibition area. You can go there, you can use them. Please do, they haven't been used a lot. Engineering views. Here, I accidentally, a colleague mentioned OpenMCT, which is a NASA project, which they use as mission control. MCT is mission control technology. So NASA uses this to track their probes on Mars and so on. And I checked that, yeah, we just integrate the backend data through Socket.io and REST, and then we get the cool graphing stuff and so on. Well, in practice, I customized quite many of the components myself. And this was an example of quick hacks. So, for example, OpenMCT contained functionality for customizing date and time, but it wasn't really extensive to all places. So what I just ended up doing, I forked the whole project, I hacked on the code, I directly modified the places where it outputs the date to output the Odysseus date, and so on. That project has no future, but it doesn't need to have, and it was very effective. And many of these components I've extended so that I could write HTML into the fields and it would render it just like that, which is huge XSS vulnerabilities and so on, but who cares? And also some of these more complex ones were actually embedded as iframes from another hosted website. And this is one of the more hideous hacks that I have written. Can someone debug what that means? Yes, it's doing blinking animation of something. And what the something is that if you have a CSS inline style attribute which contains the background image URL, which happens to contain the path flashing, then it will start flashing the image, which is how these are done.
If it works, it works.
Yeah. Task boxes. We didn't want this to be purely digital stuff. So we had digitally measured physical tasks. Most of these were based on Raspberry Pi Zero wireless version. They cost about 10 euros. So it's a cheap board, it's easy to program with, get started fast. We could have saved maybe 100 euros in hardware, but spent 100 more hours developing this. So it's money well spent. And the logic could be either running on the Raspberry Pi on the box, or on the backend, or both. So, for example, the button board, which is also on display, the Raspberry Pi actually only measured the state of the buttons and sent it to the server, and the server deduced that is this a correct configuration. And actually, of each of these games, it only measured a single button. That's enough. If the players want to cheat, then who cares? And then, for example, the wiring task had logic on the box, but the backend could determine a new state that, hey, now the wires should be in this state, and so on. And one of my favorites was this plasma pressure, which had this. This is also on display, and you can use it down below. Yeah, it's in the props exhibition. So you had to keep this value within this range. And if it goes too high, you needed to crawl into the maintenance tunnel, pull a lever which released compressed air into a lighted, bubbly tank. And if it goes too low, you had to go outside and close a huge valve for a while until it started going up, and then released it. And of course, when you were in the maintenance tunnel, you couldn't see this value. And the noise level was such that shouting was also a bit difficult. So
You're saying that it actually did something if you didn't do those things?
yeah, if it went beyond those ranges, which were a bit approximate, it started damaging the impulse engines approximately 1 percentage point every 10 seconds. And I guess in all runs it did this. And in some runs they got it fixed only after the impulse engine was at 0%.
I love the one that there has been override that 800 and 730 below that.
Yeah. And then a lot of other stuff. Info screens that were located all over. Airlock displays. We'll have a bit more on that later. SIP phones, so you could call between rooms with the ESA Data Hub, which had a lot of technical problems, but I'll mention them later. Land team video feed, which again, you need to use simple stuff. The more complex the problem, the simpler the solution. That's a Discord video feed. So there was a laptop sending in Discord the video feed. The star map and jump UI on the bridge. A mission tracker, so a mobile device on the land missions showing where to go and so on, and security cameras all over. So lots of different kinds of systems all integrated into one whole. And how were they used? ESA Data Hub messages 5,500 over 2 days. That's one message every 30 seconds around the clock for 48 hours. Most of those were from players to this EVA and NPCs, but also player-to-player messages were 1 per 5 minutes around the clock. EOC Data Hub logins 1 per minute. Hackings were also used somewhat, and news entries. But this also shows how the different runs differed in the level of how much those were used in the game communication. And moving on to the AV part, we talked about DMX. When I came to the project, I had no idea what DMX is. And well, we'll show something later on what I thought was simple and others couldn't quite grasp. And I'm sure also you were pretty frustrated with my questions on how does this DMX thing work. So a brief overview. It's essentially a standard protocol for controlling stage lighting and effects. Uses RS485 on a physical level, which in practice means that you can interface it from Raspberry Pi or Arduino or stuff like that, but it's not as simple to interface it as like normal RS232 communication is. You need a bit more electronics in between. A series of frames are sent continuously, one after another, each of which contains at most 512 channels, which are 8 bits each, so value from 0 to 255 each. And different data sources are called different universes. They can be combined, but I guess it's not very typical. In Odysseus, we had 3 universes, one for empty epsilon, one for the backend, and one for spectral calibration.
Yeah, we had 3 universes coming into the lighting desk, and then we sent, I don't know, like 5 universes out to the lights and everything else.
We could have used 3, but we used 5.
Yeah.
We could have used 255, but we were just lazy.
Yeah. And also in this case, events, so individual events are indicated by putting the value, having the value at 0 and putting it to 255 for approximately 1 second. So essentially the leading or the rising edge is there the trigger.
This is something we did not because of how DMX works, but because I, as a human being, could see a light blink for 1 second on the screen, and I was like, yeah, it's working. So that's why we had it on at full for 1 second.
Okay, good to know. One thing that I'm still a bit wondering is why everything was as events and nothing was used as a sliding value.
Because it was easier for me to program it on the lighting desk, because how I would have had to do it if it was a sliding value, it would have required functionality that I didn't want to use.
Yeah. So I guess if we wanted to like control how much smoke was emitted from the backend, we could have used a sliding value.
We could have done that, yes.
Yeah. And also one thing to note is that there are good adapters and poor adapters. So we used the Ntek DMX USB Pro, which was recommended in several places. And Ntek also has OpenDMX USB named product, which reportedly has reliability issues. But there are good libraries available. So it's, for example, in Node, it's just a few lines of code for sending DMX signals.
Question: are the adapters expensive?
No, they're not. I think they're less than 100 euros. Henkka knows best.
Well, you can get away with like really cheap stuff if you want, and it will work fine. It's rather simple protocol after all.
But I think these Ntek ones cost like 70 to 100 euros.
Yeah. And they are professional grade,
Yes,
so
and they will actually work. Okay, now do the good stuff. I mean the stuff that I understand. So I will talk not so much about tech and more about what we did as in design, how the magic happens. ESS Odysseus, the map, a better picture of it. We had 19 unique spaces that we needed to do the lights for. Mia said earlier that there were, 34 spaces in total, but we didn't have lighting in all of those. And not all of these had controllable lighting in them, but we had static lighting in a few of the spaces. Yeah. We had a bit over 200 lighting fixtures, or things that you can count as lighting fixtures in the lighting console. About 34 speakers, some of them subwoofers. We had 6 haze or smoke machines, and 1 DMX winch that we used to raise and lower the main airlock door. The starting point for my design was close cooperation with spatial designer Mia Makkonen, sitting there on the front row. And we talked, she had like a very good idea already on what the lighting should be like and what kind of part it should play on board. And this is a picture from Mia's concept file, from the very first concept file that she did.
That was really amazing.
It was very professional, and we were like, oh shit, we have to up our game because this looks so nice. So I made like a whole concept folder myself, just to show her that okay, I can do this as well. I went on developing my lighting design vision as I usually do with concept pictures, as I call them in Finnish, ideakuvat. I guess it's concept pictures. And it was based quite heavily on what Mia thought it should be, but then I put some realism into it. And I had one-to-one talks with the space head. I guess the actual name is location manager, but I like space head, the head of the space. So each location manager, how many did we have of them? 20-ish or something. So I talked with each of them, kind of like I usually have a talk with the set designer in theater projects, like what do you need from the light and what my vision was for the light in each space. And we went through that and developed it further through our talks. The lighting design in general, I wanted to have realistic, recognizable science fiction aesthetics. So I went for blue, cold, green colors and hues with some accentuated yellow and orange colors. It's good for the eye to have opposite colors so that your eye doesn't get tired to all the blue. We had a lot of ambient light, mostly to cover it up that it's actually a school. It's good to be dark on a spaceship, and the light played an important part in signaling the different changes that happened on board. Like if you would have a red alert, or if the ship took damage, so the lights would blink on the front of the ship if the front shield took damage, and if the hull took damage, there would be a lot more blinking all around. How I usually do a lighting design is I emphasize the set. So what is the best in the set? What is the stuff that I want to show? So emphasize that. So we had a lot of cool metal structures. So I built on that. Let's light those up and play up. This is Nordic lighting design. Play up the set. And I used the diegetic light, so the light like had a function in the story, like it was in the story, part of the story, and not something just added for the players, but it was like a signal for the characters that something's going on. How we ended up doing a lot of the set and part of the lighting was we had a lot of recycled stuff for the set and part of the lights as well, actually. And so the project seemed to revolve around recycled trash meets creativity meets high-end professional rental gear, and kind of put all that together, and then cool stuff happens. Next. Here's I think these are the three most important parts of our production. That's me, that's Henka, sitting right there, my trusted techie. And then in the middle, the Grand MA2, our lighting desk, that we ended up running all the sound signals through as well. And it didn't crash once. Thank you, MA. This is not a paid commercial. I did 2 weeks of pre-programming with layouts and school blueprints. So I pre-programmed everything on this like maps on the lighting desk. At school, it was 2 very weird weeks. I imagined myself to be on a spaceship at school. And then I draw in like my classmates, like, come see, I'm building a spaceship. And they were like, ooh, you got blinking lights here on the map. I'm like, cool. Like Sampo said earlier, we had DMX input from Empty Epsilon, the computer game, then the backend server that they did, and then the engine room switchboard that we will come into later. And we also output the DMX output for lights and MIDI output for the sound system. That's a MIDI cable right there. It was very important. We had 2 of them just in case. So in 2 case examples of what I had for an idea with light and what we ended up doing. It all seems so dark now. The corridors. My idea was that it's on a need-to-see basis, that they are quite dim, and so that the space is defined with light, so that you can like easily maneuver yourself in the space and not hit anything. So me and I thought of these like we designed this light column structure thing, light pillar, yes. Which worked out very well. The problem I realized later on when we were in the space was that they were so like the light was so how do you say it? It was so like recessed that it was hard to see it when you were walking down the corridor. Like you can hardly see it. So that's something we did not think of when doing the concept pictures. The corridors were also the main event space for signaling the alert states, and also it was a very big thing during the jumps. So we had the whole ceiling. My original idea would be that it was dim, and there were the lighting pillars, and then the ceiling we had 35 lighting fixtures on top of the steel mesh there. And all controllable. So during the red alerts, they would all have this certain blinking pattern that they would do. And I also ended up using the school's fixed lights. There's these like what the school's lights actually are. There's like these things, but I covered them with disposable plastic plates. There's 137 of them. And I put them in place with rubber bands and paper clips. I think that the biggest failure of this project was that the rubber strings would break because of some kind of a chemical reaction with the paper clip. And I would have to go into the game area and fix them, which was great. The other case example, the jump engine. My design thought was that the engine would be the main source of light in the engine room, and engine would be the technical protagonist in the story. I think it's important to see technology as protagonist. and I thought that the engine should be massive, radiant, dangerous, colorful, interactive, and hard to miss. We ended up improvising quite a bit on what it would be. This is from my small-scale model. It's here. It's a beer can. Or part of it, and I thought it should be like a nuclear reactor, and we have these we can use, and then more like a nuclear reactor. Oh, we found this like from the trash dump somewhere. Yeah, it's like an old disco. It's like an old disco centerpiece you could have, and those are like moving mirrors and weird stuff. And you would have light coming out. It didn't work. We tried it. But then we put it in the middle of the machine, and we put some of those LED tubes on it and pimped it up a bit, and it turned out pretty okay.
I was collecting lights, and he was going to throw it away, and I was like, no.
Yeah, we want that. Yeah, we put some paint on it, and then we put these nice LED tubes on it, and hold the whole machine around it, so it worked out well.
There's a video later on.
There's a video later on. Audio. No, I don't know much about this. We had 3 people on the sound design team, Hannu Niemi, Arne Lindén, and Pentti Hämäläinen. I think that one of the big things was that the jump should feel like something, and it vibrated the whole structures of the building. It was a huge thing that the jump, during the hyperspace jump, everybody would notice that something's going on. And they focused a lot on diegetic sound as well. I think the only things not in game,
explain diegetic.
like so that it's like in-game sound, so that it's not like, so that there's not like in a movie you would have like a soundtrack going on all the time that the characters don't hear. But in the game, it began with the national anthem, which was kind of if game, and then the game would start, and then it ended with some music that was like a subtle way of easing the players out that, okay, the game is soon ending, we're playing this music, and then the national anthem again. So it was kind of like leading the players out of the diegetic world. More about audio. Yeah, like I said, 34 speakers, 8 of them subwoofers to give the vibration. And the school with all the metal stuff, it really vibrated during... They were massive. And it was an automated system, so there were only a couple of things that were manually fixed. Yes, a question?
No, actually, a comment. As a local player, one of the good things that happened to us is that we asked for a water can into the engine room, and it was a metal one with a metal lid. And the subwoofer that was right on the other side of the window, when the metal can happened to be on a certain shelf of the room, the lid actually rattled, like you have that like sound in like cruise ships and that. So you actually got the feeling that okay, things are moving on the shelves.
Yeah, and actually I noticed during the second game we left the whole thing there. It moved. Yes, we moved. The whole thing moved, so it was like half on the shelf when I went into the room, and then was like, shit, I don't want this to like fall on the floor, and I pushed it like back a whole lot. I was told that there were more than 300 unique sound clips from 5 seconds to over 10 minutes long. Case 1, main airlock. Main airlock. So my things. Light. I thought, so we made this moving door. IT, could you send the lighting desk a signal when the door should open? And then IT goes, sure, done. And then audio goes like, sound guys go like, oh, cool, we'll make a sound for it. And then I go like, oh shit, we gotta add some more lights because it's so cool now.
And I have to comment on the IT sure done. We already had an endpoint in the backend for the admin UI sending manually DMX signals. So basically having Hanska send a DMX signal was just adding a button and having it fire one REST API call, and that's it.
It sure seemed like magic to me.
It's the framework.
a video. Will it play? We don't know.
The slider's fucking in my head. Go faster! Go faster!
It was intentionally made pretty slow, so no one would be left under it.
No, it was made of thin foam, so it wasn't heavy at all. I think it was only used like a couple of times per game to dispose of radioactive material and androids.
Close!
But yet the maintenance personnel, for disposing some of those things from the airlock, yes, I did slide under it before it closed.
Another case example, the table scanner in the medical bay. The table scanner. So we go, we've got the sound for the scan and cool lights as well, but we don't have anything the players could start them and the scan with. So like we would need like a button they could push or something. Can you fix this? And then IT goes, okay, they will use this Hanska to do the scans anyway. We can just send you a DMX signal when the scanner starts. And we're like, okay, cool. Awesome. And then a video of the scanner working. Notice Antti, who is moving the scanner. It doesn't move by itself. And what you can hear is a low rumble. It went on for 30 seconds, and there was a pixel LED strip inside the movable structure, and then there were subwoofers below the table, so that when you were on the table, actually the whole table would like vibrate when the scanner was on, which was quite awesome.
Yeah, actually, my previous comment was related to this case example. In the airlock, there was actually the whole airlock display and logic built in because there was gameplay mechanics that a particular character at one point of the game will commit suicide. And there was a countdown. The GMs wanted a countdown of 10 minutes before the airlock opens, during which the other players can either leave last remarks or desperately try to prevent it from happening, which of course wasn't possible.
Tragedy.
Case 3, fuse boxes.
Yeah, so more on the engineering side then. Here, we wanted these physical tasks. So one of the things that I came up with was a fuse box, which would actually blow physical fuses. And I had a Raspberry Pi controlling a board which used 12 volts to blow glass tube fuses. All of this works on 12 volts, so it's safe to touch even though it's on. But of course, there's a main switch there. And at some point, I realized that I could easily wire one of these fuses to an external relay so that we could, using the 12 volts, we could control mains power and, for example, cut out monitors. But that was steeping onto the latter point of the development, and it was like, do we have time to make these modifications for them? And Essi asked that, hey, you have these fuse box things. Could we get a signal that when something is broken? And I was like, well, yeah, I can send a DMX signal. Yeah, okay. Well, we have these relay boxes that we can control using DMX.
So we can like switch off the screens, which we're supposed to do, and everything else. So, and when a fuse was blown, we would I made the lights change. So like in the science lab, for example, the fan in the ceiling would stop running and the lights would go off. And on the bridge, all the screens, most of the screens would go off and the lights would dim if the fuse was off. So an engineer was in a terrible hurry to engineer to the bridge was one of the most used announcements in that.
Yeah, and this is again an example that when we started discussing things, there was a much easier solution that produced a much better outcome than I could have ever hoped to do myself. Also, one point that I realized again pretty late, but which was fortunate, is that it's a feature of the schematics that it uses the 12 volts to measure whether these are broken or not. Meaning that when you turn the main switch off, it detects that all of them are broken, like we saw in the example earlier. Which meant that when there was a single fuse in each box which was functional, which triggered the DMX signal. So there was only a single fuse which would cut off the screens on the bridge. But whenever an engineer went to fix even another fuse, they would need to turn that main switch off, which cut off all the displays on the bridge. And to make it more urgent to fix those, we tied these fuses to the life support system.
Well-designed spaceship.
And of course, we provided the players two replacement fuses so that they would run out and would have to improvise. And this is built, we provided suitable sized screws that could be fitted in. And also in later runs, if that was done, then other more problematic tasks would break.
The engineers also had the multimeter to measure those, so they didn't have to visually inspect.
I detected very early on. These are very lightweight fuses, 160 milliamps. And it's impossible to see whether it's broken. I would have wanted it to be visually clear, but that wasn't just feasible. And there's a video of blowing the fuses. There is blowing them, one at a time. And I've counted that. Including Ropecon, I've probably blown something like 500 to 700 fuses. And I've bought Partco out of these fuses twice.
And now they're wondering, what the fuck are you doing?
They haven't even asked. So then into the biggest case, the jump sequence. So the jump sequence was a very central point in the whole design of the game because the jumps pace out the game. You need to have the regular jumps. You're running away from the enemy. And there's delays and stuff like that built in. The actual implementation there, again, once we had the framework of the rules engine and the data blobs, the backend logic for handling this jump implementation is only 500 lines of code. And that includes breaking tasks when premature jumps are done, coordinate changing, empty epsilon syncing, jump crystal counts, etc. And in addition to this, there was like a main data blob which handles the actual functionality. And next to it sat like another data blob containing auxiliary jump drive state, for example, temperature and
tachyobaryonic coherence and stuff like that that we wanted to display to the users, but which didn't have functional meaning in the actual jump process. And that was about 150 lines of code. So not much. And here's a state diagram. When I was getting up to speed with what the GMs wanted out of the jump sequence, I eventually drew this, and this clarified everything to me.
I didn't feel that way.
Yeah, then I showed it to the AV crew, and hey, this describes it, and okay, well, we had a couple of meetings, and
I was like, what is essential here? So then we came up with a plan of what to do.
Yeah. So from a software point of view here, there are these different states. I'm not going to go through this in detail. I have it separately. But I decided to send a DMX signal on every single state change so that if it is needed, it's already there. The AV team doesn't need to ask that, hey, we'd want to know when from preparation it jumps back to ready to prep or whatnot. It's already there. There were a few iterations of this to make everything work, and also how this is communicated in a manner which then Essi can use. But it ended up really well, and we had then this separate document mapping what are the DMX channels, function names, what are the corresponding MIDI channels, what the effects there are. And I think you used maybe a third of all of these DMX signals that we were sending.
Yeah, sounds about accurate.
One question about the diagram. There's part that says GMs do sanity check. Is this when the GMs like ask each other like, why are we doing it?
It's good to do it every 3 hours.
It happened a lot more than on that diagram.
I already quickly showed this, the admin UI. I created this separate view for the jump drive, the whole state, countdowns for different statuses, what the jump type is. There were 3 different types, non-braking, minor braking, and major braking. Coordinates, temperature, which is shown. This was the auxiliary information and coherence. And also action buttons, which depended on the state and countdown and so on. So every time the state changed, the GMs had different buttons here, which were color-coded that, for example, this is in the engineering preparation, where they need to do spectral calibration, which needed to be manually checked from the lighting desk and then marked as done. And then the jump reactor, which could be marked as done, but it should be done by the players, and so on. The actual flow in larger chunks than what was in the state diagram. So after a jump, the next the jump drive is in a failed state, and this reactor realignment is needed before the jump drive can be used the next time. This actually used a Chernobyl reactor simulator, which has been built by ERO. Originally, it had also this huge mat where you could jump on the rods and smoke is coming out and stuff like that. But custom software was written for Odysseus, and it was integrated with the backend so that we could detect when it is done. And basically, what we decided is that you got some kind of code. You would find a light pattern in a paper manual because the ship's database has crashed. And you had to use the knobs to get the same pattern there. In practice, there was a huge amount of bugs in this system. So you first set it to the correct position, and then you committed it using the big button there.
That you chose to use Chernobyl reactor.
this is just a coincidence.
Yeah. The first run had a fortunate bug in it, which meant that even though you couldn't get the lights correct, every time you push the button, it was successful. And when we weren't able to tune out all of the bugs and make it really stable, we decided that in the later runs, it works that way as well. So it was an honor basis that, hey, try to do this as good as you can and then commit it. But it was cool anyway. Then there's cooldown phase. So the jump drive needs 2 hours 15 minutes from the previous jump in order to be used. And this was for pacing the game. And it was 2 hours 15 minutes since the start of the previous jump, so that the different lengths of jump didn't interfere with it. And after the 2 hours 15 minutes, you could enter the new coordinates and do the engineering preparation tasks, but you couldn't do a regulation jump before 2 hours 47 minutes. If you did a jump prior to that, all hell would break loose, and
It was a breaking jump.
yeah, it would be a major breaking jump, and I think it broke something like 70 to 80% of the ship's systems. And basically, this is to provide pacing for the game, and also when the enemy fleet arrives at an inconvenient time, you may be pressured to press the jump button a bit prematurely. And I guess in each run, we did it so that the first jump is a minor braking jump. So the engineers get something like 10 tasks to do and fix, so they get a bit of a hang of it. And then on the next jump, we dropped them into the deep end of the pool. So after the cooldown period, the coordinates could be entered. This is the LoRa Science Voyager, aka Jump UI on the bridge. There would be a star map on the background, but it wasn't working when I took the screenshot. And once this was done, there was a ship-wide announcement to keep everyone up to speed on what is going on. And after this, the jump drive went into calculating the jump vectors, which meant the GM sanity check. So if the players would be doing something really stupid compared to what we were planning, we could abort it. I don't think this was ever needed. There were there were also some cases where we intentionally just left it hanging there so that they couldn't jump away from the enemy fleet. I wasn't aware that it had been aborted.
Are you sure you want to jump in this place? Yes, we want to. No, are you really sure?
I at least did it twice or 3 times.
Okay, didn't realize that.
We were heavily railroaded to a particular orbit.
Well, otherwise you would have missed all the fun.
I didn't mind. It was very nice.
Fun, you say?
Fun.
Fun.
Type 2 fun, to be exact.
So then, after the coordinates are entered, there's the engineer prep, which had the same reactor realignment again, and also the spectral calibration.
Yes, the spectral calibration was essentially a very old switchboard that we found from a friend of mine's backyard. Trash. And we connected to an analog DMX converter. So, and actually 15 of those switches were actually connected. So you would flip the switches, and then that was connected to the lighting desk, and then the LED tubes inside the engine would change colors, and you would have to match the colors to another color of different lights inside the machine, i.e. do the spectral calibration. And it was actually very easy to do. You would just have to follow a chart, but it took time, and it looks difficult for others, so it looked like the engineers knew what they were doing.
And again, after that, there was a ship-wide announcement to keep everyone up to speed. And then the actual jump, it's again initiated from the bridge, from the jump UI. There's a 60-second countdown leading to the actual jump.
Yep, leading to the actual jump. I think that the whole game greatly benefited from the cyclical structure of the cooldown periods of before the jump. So where they're like 2-hour, 3-hour periods of like building drama, and then always the enemy fleet would arrive in the end, and then there was the climax of the jump. And we tried hard to make the jump feel like a climax. It was highly visible, it was loud, you could feel it. There was a lot of low frequency sounds that vibrated the whole building. I was told that in some of the sleeping quarters they didn't wake up during the jumps. And the jump itself was followed by this Star Wars-esque in-jump period that lasted from a couple of minutes to, 10 minutes, which was a hectic time in the GM room when the GMs would be like, oh, what we'll do now? And are all the systems running? And should we boot up the sound system? Is it working? Is everything in check? Where will they go? What is happening? But we tried to make it so that for the players or the characters, it was like a quiet, dim, mysterious in-between when you were not really in one place or another, but it was just like a moment to catch your breath and be in the being.
And one of the things I and many others found really cool about that soundscape was that it really, at that point, you heard what you hadn't heard before, what was all the ambience that was running all the time from the life support and engines, and there were, something like 5 different layers of sound ambience running almost all the time. And that disappeared and was replaced with something eerie.
The jump.
The sound doesn't make justice. And the
Absolutely zero based.
And the really cool thing was that Essi could really do magic manually during the jumps. So in one of the runs, the players decided that, hey, we have this weird alien device. What if we plug it into the jump drive? And we want to charge this stuff. And the GMs were like, okay, yeah. They practically invited people into the jump, into the engine room to watch it. At that time, at the same time, Essi was scrambling that, hey, what can I do here on the lighting side, while I was browsing through my code that how can I make this temperature jump through the roof immediately, which in the end was possible. And well, these were in most cases these were just lighted fully on the same color, but you could program it so there was clearly different vibration and different colors flashing there.
Yeah,
so,
when they come out of the jump, it's all like weird wiggly woggly thing, and they're like, "What is going on?" And then there's a GM at the door handing radiation poisoning.
Tray. Which radiation would you put?
and of course smoke filling the room and so forth.
Naturally. Questions?
Question about setup. Where did you put the woofer in this room?
there was quite a lot of fake walls in this room. There was also the tunnel, so there was a subwoofer behind the engine, and then I think another one further into the room, like behind the fake walls. And there was also one in front of the engine room.
This is one of the cool things on the school was that all of these rooms had glass walls, so you could easily see them. You could just walk past the bridge and see everything that was happening. This is through that, and pretty much next to me was the main subwoofers making everything rattle. And the first time that I accidentally was next to them during a jump was quite an experience.
Another question.
Not so much a question, but a comment, because I called it railroading earlier. And obviously, it was obvious for the players that it was at runtime. But for the characters, it didn't really feel artificial, because we were being shot at. And there were lights everywhere, and jump preparations should have been studied, and we were getting the coordinates wrong repeatedly. And it was all run through the ship AI. So we were not talking to a GM, we were talking to the ship AI who kept Eva kept on rejecting the coordinates and being shot at, and the captain was like, get on with it. so it was, I felt it was well done, because all the effects around the players added to the feeling that this is urgent and we're working on it, even though as players you obviously do that.
Yeah, so an illusion of non-railroading was present very highly.
There was a very strong illusion of not being railroading.
And there were a few places where you could choose where you jump.
Yeah, but this was not.
Yeah. And this was obviously like a clockwork LARP, and there are a couple of really good analysis of that online. One thing that caught my eye originally was that the main GMs had this huge Excel sheet which contained the LARP events at 15-minute granularity. So that's railroading for you.
About the sounds for the game. Actually, if you go to see the gala tomorrow, where's the costume, what is it, costume show, actually you might hear some of the sounds from this. With less bass.
Yeah, so I just had a couple of these behind-the-scenes clips. Thought I'd show a bit like what's behind the bridge.
You're killing the magic, man.
So there was a maintenance door next to it. There's all the stuff. Huge amounts of laptops. These are the stands that are holding up the displays because what was built couldn't handle that. Lighting, huge amounts of cables everywhere.
It was an old spaceship. Come on.
There's the network switch above there. More cables and stuff. And also over here you can see the Raspberry Pi of the fuse box that was...
in the last corner there was the laptop for using the announcement board. And it was too bad when during the game one time it froze and we would have to go all that way to fix it.
And, well, this isn't really behind the scenes, but,
Inside the scene.
yeah, so the maintenance tunnel. So, this was where this plasma pressure release was, and this was where the life support tasks would break if you had changed the fuses into screws.
It's actually a dog agility tunnel.
And of course it was much darker, and there was this slowly blinking ambient light, I had this flash on because otherwise you couldn't just see anything from the video.
That was the compressor that was on for the pressured air.
There's the pressure release handle, and then this. There was a fan behind that all the time blowing.
And that's where the smoke came from.
So a few conclusions. So lessons learned. Keep it simple, stupid. The more complex the problem, the simpler the solution needs to be. For that kind of video feeds, use some ready product. There in the SIP phones, there were huge amounts of problems getting them done. And I don't think they were really very much used in the game because they were a bit cumbersome on the laptops. And they could be replaced with just PMR phones, which were somewhere given to the players. So there, again, the balance of work versus game benefit. Quick hacks provide more bang for the buck very often. Integration testing plan. Everyone tested their parts. They tested that, yes, when I get the signal in, it works as expected. But there should have been someone who is responsible for the whole of the integration testing and also designing and planning that. What are the requirements in order for testing this? A few times I asked for, will someone do a plan? And one of the main GMs said that, yes, I will do it. And of course, they didn't have time. And for example, of these interdependencies in testing was having a network, which we had, I think, 2 days or 1 day before the start of the first game. 1 day before the start of the first game. The first full jump cycle, which we did, was the day before the game started.
When the players were already on site.
Hmm?
When the players were already on the site.
Ah, okay. Yeah, so players were on the site when we were first time testing that stuff. Taking that into account, it's a testament to the professionalism of everyone that it worked as well as it did.
And a fair amount of good luck.
Well, yeah. Communication. So it's a very diverse team. So communication is key, and everyone needs to understand that the language you speak and the way you understand things is not the same as others. Keeping the game time options open. So basically, in an ideal situation, you can improvise as a GM. For example, during that one jump, I checked that the jump drive auxiliary code checked that, okay, is this a non-braking jump or major braking jump? And based on that, the temperature rose. And it was made so that I could change the value, and it continued rising from there. But in practice, what I had to do was jump it up a couple of times until it went over the border where the graph was drawing. And actually, after that, it started going down towards the major jump attempt. So if I would be writing this now, I would have a parameter there that this is the target temperature where this temperature will go in approximately 5 minutes. So I could just set that to 15,000 degrees or whatnot.
So maybe a lesson learned, like aim for an autonomous system, but make tools for improvisation. Like I could have done a whole lot more like what could I do during the game? Like if something weird happens, like I could have prepared stuff for that, but I didn't. So during the game, I would just have to improvise and blind so that I couldn't see what I was doing. So I could have done that beforehand, had I known.
But that said, a lot of this was done. So, for example, in the jump system, there were these buttons, and you could, during the jump, decide that, hey, in the first run, they built this massive cooling system out of everything they found. And we were like, okay, you'll get one braking jump to become non-braking. And correspondingly, some others changed to braking and stuff like that to be done on the fly. So try to make stuff that works automatically, but with which you can tinker during the game. Rehearsing major scenes, the ending scene was really troublesome during the first 2 runs. There were cases where lots of the players didn't really know that what just happened, are we saved or not. On the 3rd run, we pretty much nailed it, but on pretty much every run, we were frantically during the last 15 minutes trying to test that, hey, how does this work? Can we get this view? No, this view doesn't work, and so on. So rehearsing those. And don't assume that briefing sessions are remembered. For example, I had said that you shouldn't, when you scan your bio ID, you shouldn't give it to someone else, because the tasks that they did, the difficulty varied depending on what character was doing them. So that was scaling this profession experience. And in hindsight, I should have just put an off-game note on the login screen that, hey, you cannot scan someone else's bio ID and provide it forward. Some gotchas. SSL certificates are a pain in intranet. So this was a huge pain point for the SIP phone. So first of all, Chrome nowadays disables a lot of functionality if you're not using HTTPS. So it forces you to use HTTPS. And it also disables some functionality even if you use a self-signed cert which you say that, hey, I want to use this. It still disables stuff. And for example, for the Hanska, it was a single-page app which you could install as a full-screen application, but we couldn't just get it working in the intranet, and it had these browser header bars during the games. One workaround for this would be to have created an external domain name, obtained a valid SSL certificate for that, and then pointed that domain name to the intranet IP address. But we just didn't have time for that. Radio interference. There wasn't much of it, but I guess some of these PMR discussions were a bit garbled,
Yeah, but that's something that maybe cannot be helped.
Yeah, and basically think about where you can trust wireless when there are hundreds of pulse width modulated lights around. OS configuration. Still hours before the start of the first run, we had all of the laptops shut down every 20 minutes. Which was like, what the hell? Why is this doing it? And finally, we found some very obscure like settings, power settings, advanced options, profiles, and it was on the option of timer and needed to be something else. And that was a real issue that was discovered really late.
Also, it was very important not to let Windows update itself, like we had the sound computer update the Windows or like complete something during one of the jumps, which was very interesting. It was a quiet jump.
And also
disable them. During the third run, every single screen got a pop-up. So Windows has an update ready for you.
Regarding that Windows update, Windows has decided that even though you disable the system running the update system, if the Windows server decides that now you're getting a major update for Windows 10, you will get that, even though your service is not running. So disabling the service didn't cut the pop-ups. We had to say that, okay, sure, update, but do it next Monday.
Yeah. Batteries, moving cables. So the video feed had issues with batteries running out and cables being pulled out. There again, simplicity is key. Could have maybe used just a phone with a wide-angle lens there.
And then always check your cables that they're okay.
Some resources, the slide set is available there. You can take a picture if you like. There's also a QR code to open this slide set. All of the code we've written is available on GitHub, open source. Taskbox schematics and descriptions are available. They're a bit scant on details in some places. Empty Epsilon and OpenMCT are also useful.
All right. And then for questions and answers. When all phones are down. Yes.
Maybe we can leave that on.
Well, everything went well, but did you have a plan B, C, or D?
Yes.
For what?
For practically for everything. So for example, the Hanska was for a long time that, hey, can we get this done and can we get this working? And there were backup plans. I don't remember the details, but we had different kind of contingency plans for different failure cases.
In the end, we would have gone to pen and paper, if nothing else. We had a couple of different tiers for like, if this doesn't work, then in the end, we'll just use runners and paper.
That said, everything worked like amazingly well.
For the reusability for this, do you have some kind of electrical interface documentation, or how did you handle basically you have XLR cables, USB dongles, and 7 different coding languages, I assume?
So for the technical cabling and stuff, I think that's pretty much per LARP. What you have available, what's your budget, and so on. For the code, I'm hoping to write some more documentation on how this could be reused. Basically, that the backend would be the most useful part, and there, for example, the data blob and rules. And the Odysseus functionality is essentially an example implementation which you rip out and put your own implementation in. And also many of the others like the Hanska and task boxes and stuff like that which interface with the backend can just be rebranded.
Did this cool have curtains to block the outside words and light Finnish summer? Or
yes.
What did you do? Because I saw this was very big.
Yes, we'll use the whole lot of mansikka muovi, which is used for, it's black plastic, used for covering strawberry fields. So we use the whole lot of that and a lot of tape. How you make a spaceship is that you take some trash and plastic and tape, and a spaceship occurs.
And also a lot of tin foil on the outside to cool down the building.
Does your team have plans to do a sequel?
No. I've already publicly on Facebook promised that if someone wants to use this code in another LARP, I can consult them on how to do it.
Let's give Sampo a couple of years. He'll come around.
But I mean, yeah, the framework is there. It works. I can give instructions how to use it.
And I think it's,
Easier next time.
Hopefully.
and I think it's really important from all of this, like that it should, like all the code stuff and everything. It would be really great if it was reused in some way, so that it wouldn't be a one shot thing. We are now in the end of the thing. Those are mines.
It's a minefield.
Thank you.
Thank you.